My name is Jared Hall, and my research topic is about 3D printing and more specifically, what it does in the medical field. Have you ever wondered to yourself what the next big thing in science is? No? Don't worry, I hadn't either until I first came across this topic, 3D printing. Now when I discovered this, I was absolutely shocked that we are able to 3D print body parts. Now as you're sitting there watching this, you must be asking how? Well, that's what I'm hoping to teach you today, is the technology, applications, and many other nifty things about 3D printing in the medical field. What exactly can we print? What exactly can we print is a huge question and something scientists are always trying to expand and build on. Now at the making of this video, there are many things you can print. Organs. We can print organs. Well, not full organs that would be useful in surgery, but we can print certain types of organs, including kidney cells, sheets of cardiac tissue that beat like a real heart, and the foundations of human liver, among many other organ tissues. While printing out an entire human organ for transplant may still be at least a decade away, medical researchers and scientists are well on their way to making this a reality. Stem cells. Stem cells have amazing regenerative properties already. They can be reproduced many kinds of human tissue. Now stem cells are being bioprinted in several university research labs such as the Heriot-Watt University of Edinburgh. Stem cell printing was the precursor to printing other kinds of tissues and could eventually lead to printing cells directly into parts of the body. Skin. Imagine the uses that the printing skin grafts could do for burn victims, skin cancer patients, and other kinds of afflictions and diseases that affect the epidermis. Medical engineers in Germany have been developing skin cell bioprinting since 2010, and researcher James Yu from Wake Forest Institute is developing skin graft printing that can be applied directly onto burn victims. Bone and cartilage. Hod Lipson, a Cornell engineer, prototyped tissue bioprinting for cartilage within the past few years. Although Lipson has yet to bioprint a meniscus that can withstand the kind of pressure and pounding that a real one can, he and other engineers are well on their way to understanding how to apply these properties. Additionally, the same group from Germany who bioprinted stem cells is also working towards the same result for bioprinting bone and other parts of the skeletal system. Heart and blood vessels. Another German institute has created blood vessels using artificial biological cells, a 3D inkjet printer, and a laser to mold them into shape. Likewise, researchers at the University of Rostock in Germany, Harvard Medical Institute, and the University of Sydney are developing methods of heart repair or types of a heart patch made with 3D printed cells. The human cell heart patches have gone through successful testing on rats and have also included development of artificial cardiac tissues that successfully mimic the mechanical and biological properties of a real human heart. There are plenty of other developments being made with 3D printing and bioprinting, but one of the most and biggest obstacles is finding software that is advanced or sophisticated enough to meet the challenge of creating the blueprint. While creating the blueprint for an ashtray and subsequently providing it via 3D printing is a fairly simple and quick process, there's no equivalent for creating digital models of a liver or heart at this point. However, with quick developments and advancements researchers and biomedical engineers have made in a short few years, this obstacle will soon be one of the many that are overcome on the way to successful, complex bioprinting. Cancer and disease research. Cancer and other disease cells are being bioprinted in order to better understand their engineering. By doing this, it will enable better and more efficient drug testing. Drugs. As in August of 2015, the FDA approved an epilepsy drug called Spiritum. This is made by 3D printers. It prints out the powdered drug layer by layer to make it dissolve faster than the average pills, and people may be able to print their prescription at home in the near future. How it's done. The first step is to create a model of the object one wishes to make. However, instead of trying to create an organ or tissue model from the ground up, researchers and engineers can use a CT scan or MRI to create a 3D model to print. Websites like Instructables even have tutorials to describe how to turn a CT scan into a 3D printable model to print. There are multiple types of printers, including bioprinters, which Organovo made the first commercially used bioprinter. The printer has two robotic print heads. One places human cells and the other places a hydrogen, scaffold, or any other type of support. Next would be inkjet-inspired printers. Experiments with bioprinting at Wake Forest University were inspired by traditional inkjet printers. The printer allows multiple cell types and components to be used for printing. Today, the university has adapted that technology so that skin cells can be placed in an ink cartridge and printed directly on a wound. Organovo explains that basically once a tissue design is selected, the company makes bioink from the cells. Using a NovoGen MMX bioprinter, the cells are layered between water-based layers until the tissue is built. Why it's important and what it will enable. 3D bioprinting is an amazing thing and can benefit us in so many ways. One of the most stunning medical advancements resulting from 3D bioprinting can be found in operating rooms. For starters, 3D printing is changing pre-surgical planning. Doctors can use derived from CT scans and MRIs to recreate lifelike models of organs. They can make better observations and prepare for remarkably more efficient procedures long before commencing surgery. One of the most obvious ways to use 3D printing in healthcare is tools. By using 3D printing, we are able to print medical tools at more than half the price. A 3D printer was recently able to produce an Army-Navy surgical retractor, which is a common and versatile surgical tool, in about 90 minutes and at a material cost of less than 50 cents. Also, one child patient, for example, was saved by a 3D printed splint that attached to his trachea so he could be taken off his ventilator. Since then, this technology has been explored as a means to create even more life-saving and life-improving devices for both use outside and inside the human body. Funding. Now the healthcare sector will largely contribute to pushing global spending on 3D printing from $13 billion in 2016 to a predicted $28.9 billion in 2020, according to a recent IDC report. This is quite significant. My closing remarks. In closing, I would like to just briefly summarize my presentation. We have covered what 3D printing is, how the process is done, what you can print, why it's important, and what the future holds. We also discussed funding, which is a very crucial step to all this amazing work. I hope my project has enabled you, my fellow students, to learn something very exciting and new. Also, I would just like to say thank you for watching my video. I hope you enjoyed it.